All right, good afternoon or good morning. This is Mr. Who in Algebra 2 Semester 2. Today we've got another lesson ahead of us. Uh, it's gonna be an interesting one. It's called simplifying rational functions. So we have our two objectives here as well. We're gonna do a bit of factoring. So if that's something you recall covering at some point earlier in your career, might be a good idea to bring that knowledge back to the front of your mind there. All right. So let's go ahead and get started. First of all, okay, we're talking about rational expression. So as we work with a rational expression, we need to define what that is. A rational expression is the division of two polynomials. Okay, the division of two polynomials. So it's just, one polynomial over the other one. Okay. And a polynomial, remember, could be anything from a monomial all the way up to like trinomial, quadrinomial, etc., etc. Okay. So our first type of rational expression, okay, simplifying those, will be to just simply divide. Okay. Now remember, when you divide variables, we have to use something called the exponent rule, okay, rule of exponents, in order to divide that. So we'll be considering these both separately. Okay. You've got two parts. You got a number part and a variable part. Now, the number part is very easy. You can just set it aside as 7 divided by 2. Okay. And then the variable part, you got x to the 10 divided by x squared. Okay, so two parts there. They're both being multiplied together. That's what makes this whole thing on the left. Okay, 7, you cannot divide by 2, so we are already simplified there. We kind of just keep it like that. Make a bar long here. Whereas for x to the 10th over x squared, okay, that is actually going to be something a little different. If you can remember your exponent rules, remember if you divide two variables with exponents, you take the exponent of the top and subtract the exponent in the bottom. So 10 minus 2, that will of course give me x to the 8th, okay, on the top, right? So nothing in the bottom. And this is actually the most simplified this expression gets. In the second one, we got a bit more. We got a bit more numbers to work with. So let's just separate it out. Okay, we have 32 over 10. That's my number part. And then as for my x's, I got x squared over x. For my y's, I have y to the 6th over y to the 3rd. And for z's, I have z and z to the 9th. Okay, so gonna be using what I used over here. Okay, so I'll be dividing each of these out using my exponent rules. Let's do the number first. 32 divided by 10, they both have a common factor of 2, so let me take that out here. 32 divided by 2 should be 16. 10 divided by 2 is 5, so that's my simplest form there. Extend this out here. Okay. Remember, when you don't see an exponent with your variable, you understand there should be a 1, okay, a power of 1 hiding up there. 2 minus 1, of course, gives me x to the first, which you can put up the x to the first if you want. Don't need to put the 1 power if you don't feel like you need it. Okay. Next up, we have y to the 6th over y to the 3rd. 6 minus 3, that will give you y to the 3rd. And finally, we have an interesting scenario here. It's z to the 1st over z to the 9th. Well, remember what I said about the rules of exponents is that you could subtract the top from the bottom, but if we do that here, we'll end up with a negative exponent. So instead, let's just subtract for the bottom from the top. Okay, 9 minus 1, that is 8. Okay, but instead of putting it in the top, because we started from the bottom, we will put it down here. So z to the 8. Too big there. Okay. So this is our simplified form, and feel free to drop off that 1 power on the x if you feel like you don't need it. So far, so good. Should be pretty easy to, move along here. All right, so the next kind of simplification we're talking about is, we're moving into factoring. Okay, we're moving into a little more difficult bits of procedures. Okay, but we're talking about two main methods here. Okay, two main methods of factoring, which we'll cover in a sec. Those would be difference of squares and trinomial factoring. Okay. And when I say trinomial factoring, you can also remind yourself of the ACB tree, if that's something you learned with our time at Heron or somewhere else. So when I look at these two, okay, pieces of the polynomial, the rational expression, okay, I want to separate them out first. So here's my top, 7x squared minus 7x minus 14. And here's my bottom. It's my x squared plus x minus 6. Okay. So I'm going to go ahead and apply the ACB tree to both of these polynomials, okay, and see where it gets me. Remember, to do an ACB tree, okay, A, B, and C, remember, as part of your polynomials there. 7 times negative 14, the AC part, okay, that should be negative 98 because it's 7 times negative 14. Okay, and I want to look for two numbers that, when added together, give me negative 7, the B, but multiply together into the negative 98. This is actually going to be the same two numbers I just used, okay. Negative 14 and 7, okay, because we just did that, so we got negative 98, and putting those together gives us that, right? Then we go ahead and do our grouping step. Okay, that's when you split your polynomial into 4 terms here, 7x squared minus 14x plus 7x minus 14. Okay. Or you can organize it the other way around. It doesn't really matter. Okay. And then I have to do this kind of grouping idea. So let me change my color real quick so you know what I'm doing with the grouping part. You should take the first two, okay, and the second two, and we're going to split them apart. Okay. And we're just going to factor them each using the greatest common factor method. So that's from like the last slide here, kind of like the main division. I can divide both these terms by 7x, so I'll go ahead and take my 7x out. Leave myself with an x and minus 2. I did that right. And over here, I can take out a 7 as well, so I'll leave x minus 2 as well. So the goal is to have these two pieces be the same, so that you can finally separate it out to 7x plus 7, okay, and x minus 2. All right, over here it's a lot easier. Okay, 1 times negative 6 is negative 6, and I need two numbers that add up to positive 1. That should be 3 and negative 2. Okay, and a little shortcut you can do with a equals 1 polynomials is you can just kind of skip it all together and say, all right, I have 3 and negative 2, so I'm going to go x plus 3 and x minus 2. Let me go ahead and draw a bit of a barrier so you don't confuse the work here. Okay, something like that. So I'm splitting my work between the top, the numerator, and the bottom denominator here. Okay, so we've went ahead and factored those. Okay, do you see anything in common? Okay. If you've been looking at it here for a couple of seconds here, you should notice that both the denominator and the numerator have x minus 2. Okay, that's here and here. And so when I actually put them together, okay, so in other words, it goes something like this: 7x plus 7, x minus 2, over x plus 3, x minus 2. Okay, these two are the same binomial, so let's go ahead and just cancel them out. Okay, they just cross out completely. And what I'm left with after I take it again and rewrite it one more time, 7x plus 7 over x plus 3. And that is my final answer, my final simplified form for example 2a. Okay. So I will do the other example, example 2b, but if you want to skip ahead and kind of look forward to new content, you feel free to do that. Okay. I'm going to go ahead and clear it. Pause if you want the screen, otherwise I will be going on. Okay, so for the second one, I've got 2x squared plus 2x minus 12, okay, as well as 8x squared minus 8x minus 16. Okay, so those are my two pieces. Let me go ahead and draw a bit of a barrier here. Okay. So when I take this and factor it out, I can actually take out a GCF. Okay, it might be useful to do that. You might have seen that in the first one too, although I didn't want to overload your brain, so I chose not to do it. Okay. 2 times x squared plus x minus 6. Okay, that's actually something over here. We already did that factoring, so we'll look at that later. And down here I could take out an 8. Okay. So I'll take out 8. I'm left with x squared minus x minus 2. Okay, so a little different there. Now again, with this factoring bit, when we factor these two trinomials, you're kind of looking for the places where they will overlap, the binomial that they share in common. Okay. Now, we know from the first example that this will be 2 x plus 3, x minus 2. So I'll just go ahead and write that there. So when you're looking at this next polynomial, you're kind of looking for one of those two binomials to show up. Now, if you're thinking about this mathematically, you might have realized, well, there's no way I can divide 2 by 3, so 3 can't really be, I don't think I'm going to be able to get that binomial out. So you might be thinking, well, it's going to be something like 8 times x minus 2 times something. Right? We don't know what that something is, though, so let's go ahead and do it out here. X squared minus x minus 2. My a is 1, my c is negative 2, so I'm looking for something that multiplies up to negative 2 and adds into negative 1. That should be pretty simple. Negative 2 and positive 1. So again, a is 1, so x minus 2, x plus 1. So this is the little ACB tree step. Okay, so ACB right here. All right. Okay, so now again, I have my fully factored numerator and denominator. Again, these two appear again, the x minus 2, so I'll just go ahead and get rid of those. They cancel out very nicely. But also the 2 and the 8 can't cancel out, turning that into a 4, and turning this 2 into a 1. So what I'm left with is x plus 3 on the top, right, and 4 times x plus 1. And that's my fully factored form, my fully simplified rational expression. All right, I will go ahead and move on to talking about the different methods of factoring and which ones you will be responsible for in this lesson. Pause the video and look at it again if you need to. Okay, so here we have the three different factoring based on the number of terms in your polynomial. However, for the time being, you will not necessarily see four terms as the problem presented to you. Now, when we do talk about four terms, we see something using grouping. You will have to know how to group if you hope to do the ACB tree or, the polynomial, trinomial. Okay. But that is the three-term one. That's the trinomial factoring with the ACB tree, which actually then leads to grouping. So when you do this process, you will do some grouping. And finally, with two terms, okay, we've got the difference of squares. We didn't cover yet, but I will get to it in a sec. Difference of squares, as well as something we haven't really talked about, sum and difference of cubes. So I won't write that down. We're not going to be covering that today. So don't worry too much about that. Big ones to mention are the difference of squares, okay, and the trinomial ACB tree. So worry about those two first, and we will get into the higher level factoring methods later. Okie doke. Next, we have a bit of graphic. Okay, now let's take a look at the functions here from 2a and 2b a little more in depth. We'll do 2b in class together, so you won't have to worry about looking at it through the notes right now, but maybe try looking at it and applying what we're talking about here on your own before we get there, see if you have any questions. So first of all, here's that factored simplified form we got from earlier. So that's what I put down here, but remember what we got rid of was this kind of idea of an x minus 2, okay, from both the top and the bottom. Okay. So kind of think about that. Still there, but we kind of canceled it out. It doesn't actually appear as part of the final simplified form. All right. Now, let's talk about these functions, okay, these rational function where x is equal to negative. Well, if I look at the graph, I see negative 1. That's the first nudge over. Looks like about 0. Okay. So let's go up to our function and check it. Negative 1 plus 1, that is 0. And anything times 0, of course, is 0. So that does make sense. That is confirmed 0. Now, how about when x equals 2? Well, when you look at the graph, nothing seems too out of the ordinary. However, remember, we actually canceled this factor, x minus 2, from both sides. If you plug in x minus 2, or x equals 2, sorry, to this function, this top becomes 0, but this bottom also becomes 0. Because we don't actually have a way to write that out, okay, 0 over 0 anyway. There's no actual numeric value for it. We don't have an answer for this. We call it undefined. Okay, undefined. or you can say there's no point. Even though it looks like there is a point, there is simply not a point. So we actually use an open circle to indicate that. Okay. Yes, you can find a value for x equals 2 in the simplified version, but in the original problem, we had this x minus 2 set in the factors of the numerator and denominator, and because of that, there is no value there. Okay. At x equals 2, what does the graph look like? It looks normal, to me anyway, but with a hole. So there is a hole there, okay, a piece that's cut out. Let's move on here. Let's talk about the next one. Value of the function where x equals negative 3. Well, if I plug in negative 3 to the function, I look at the graph, here's negative 3. I don't see any points where the graph would touch me, maybe way down here or way up here. But truth of the matter is, there will be, again, no value there, so we call it, again, undefined. Difference here, though, is that it's not quite a hole. There's no parts of the graph that actually touch it. We call these things asymptotes. Asymptotes. Okay. Asymptote. All right, so let's go ahead and define it for us here. Points of discontinuity, that's the entire point of this little section here. These are points where the function is, I can get my pen over here, undefined, since the denominator equals 0. That's the big part here that causes issues to happen. You cannot divide by 0. Hopefully you all know that. So when you have 0 in the denominator, that of course causes some issues, and it's the entire point of this discontinuity idea. Okay, so next slide will be our last slide for the video notes, and then we'll talk about it more in class, okay, at a better detail. Right? Okay, so we are going to cover two different discontinuities here. I will color code them, just so you are aware here. Okay. The first one we covered in that example above is called a hole. Okay, and the hole is kind of like what it says it would be. Okay, it is when you have matching factors in the numerator and denominator. So in other words, they cancel out. Okay, so this is where you would set the factor equal to 0 and solve. So for example, we have x equals 2 from our example above. Okay, remember the factor we canceled out was x minus 2, okay, in both the top and the bottom, and we set that equal to 0 and just simply solve using our basic algebra skills to get ourselves x equals 2 as the whole. It doesn't have any difference in terms of how you draw the graph, but you just put the hole right on that spot. Okay, and the second type of discontinuity we covered is the vertical asymptote. Vertical asymptote. So this would be our x equals negative 3 from the above example. Now, this is when you have remaining factors, remaining binomials, factors in the denominator. So if you look above, we have that x plus 3, okay, in the denominator. And that, again, you have to set the factor equal to 0 and solve. Okay. So same principle applies. Okay. Now the difference between these two is that the vertical asymptote is actually a line which the graph avoids at all costs for rational functions. Okay? Whereas the hole is something that it kind of will go through and just kind of ignore that it's there. Right? Just rolls right over. And those are really the only two we're going to talk about at this point in time. Okay? So really get to know those, okay, in terms of factoring and displaying and recognizing these on a graph. Okay, you will not have to graph them just yet. Okay, we're just looking at analyzing the pieces as they would appear on a given graph. Okay. I think that is about all for the video notes here. We will cover the rest in class. So Please jot down any questions you might have. Okay, make sure you take a screenshot of your notes so that you can turn it in with the bell work, and I will see you all in class.